Hello, John Capobianco's back, and I had such a great outpouring of interest and excitement and messages and support for the previous video in one direction. Meaning in the MCP, can I say, can you go get the state of the network and draw it out in DrawIO? And we see the squares and the connections and everything, right? That's one direction. That is incredible. The immediate feedback, and everyone's a step ahead. Can we do it the other direction? Could we draw something in DrawIO, read it, and then understand it and potentially generate and push config from it? Now, this is Shangri-La, because in the world of true operational networks, the way the real world works is you've got operators, engineers, architects. And the further up you go towards architecture, the more and more you are involved with diagrams. Right? An architect may only deal with diagrams, interfaces, OSPF areas, BGP, right? They draw it all out, and that starts to percolate down. And as we move to engineers, they turn these designs into configs. Operators push and operate the configs. Imagine if we could cut out all those layers, and the architect could be empowered by making their diagram, maybe vetting it with other architects and engineers and operators, and then generating and pushing the config and always using the source of truth. Now, source of truth is thrown around a lot, and most people think of Netbox, Autobot, ITSM, databases, things of that nature. The real source of truth, when the shit really hits the fan, is the blueprint, the architectural diagram. What was supposed to be connected to what? What are the IP addresses? How was this intended to be hyper-connected? It's all driven by the blueprints, and you might need to reference 5 or 6 different blueprints to put it all together, depending on the OSI model layer that you're looking at in the diagrams. It might be a layer 1 diagram, could be a spanning tree diagram, could be a routing diagram, area diagram, neighbor diagram. See, the dog she knows what I'm talking about. Imagine if we could take that visually and just derive and push config. So let's get into it here. Quiet. We're going to look at some code first. So I've had to update my front end to have a get all cells function. Okay? I'm going to work from the front back. This isn't necessarily how I coded it in order. But this is the browser listener for for a get all cells method. Now in my index here, I had to add this get all cells and register it as a tool. And in my system description here, I've added the get all cells as a type hint. So when I bind this tool to the LLM, it understands how to interact with this tool. So let's go ahead and bring up the containers, including the DrawIO containers. So let's just take a look at the containers. We've got the pyATS MCP, which is stdio, my DrawIO MCP, which is listening on 2 ports, one to stream to the browser and one to receive from my MCPyATS client. So you can see all the tools have been discovered here. And you can see here all bound tools. We can see that we've bound this get all cells tool. All right, so now the LLM has access to that tool. And I'm going to launch this DrawIO browser. Okay, I'm going to launch it with a specific URL, an offline URL with no HTTPS. And we're going to open an existing diagram. This gets really cool. There's the diagram. All right, and if I show you the sandbox that we're working with, I'm not interested in Switch 2 or these servers. Those are sort of different Linux hosts with a different operating system that I don't want to interact with. I'm focused on PC1, PC2, Switch 1, a router 1, and even this point-to-point link to router 2. So I've sort of drawn this up here, but more of a logical topology view. All right, so we have router 1, router 2, and I say ETH01, ETH01, And just to show you I'm not cheating here, right? If I go on to router 1 and I do a show run in ETH01, right? There's no IP and no shutdown. Now I also have ETH00, and that's the southbound facing interface to the switch. And it has no config on it either, right? So I've blanked out all the configs across the board. And what we're going to do is see if we can get it to set up these sub interfaces, set up this ETH02 as a trunk link, and see if we can establish pings between these PCs. So right now, if I ping from PC2, ping 10, 10, 10, 100, I'm going to get nothing back. And from PC1, if I do a similar ping, ping 10, 10, 30, 100, we get nothing. So let's do some vibe coding. Can you please help me understand the network topology in DrawIO? Help me understand the diagram as if you were explaining this to a junior network engineer. All right, so what's going to happen here? And let me hit F12. We're going to see in a couple of seconds here, this DrawIO MCP receive the get all cells command from my pyATS MCP, right? So if I jump into the pyATS MCP, whoops, wrong one, we should be seeing a get all cells command here. Is it done here? I didn't see anything happen. It must be asking. I'm going to say, can you use the get all cells and read the actual DrawIO network topology, please? It didn't actually invoke the tool. I'm going to have to tweak that. So now here we go. Get all tools, all right? And the get all tools in the DrawIO MCP is streaming back each of the tools from the get all cells, and we can see the metadata associated with that. So now in my Streamlit, here we go. Devices, switch 1. This is a switch represented by a rectangle. Router 1, router 2, PC1, PC2, their IP addresses, the connections, the network layout, the IP addressing. So I'm going to say, can you please propose a network config? Actually, let me go back 1 second here and add a couple things. I'm not quite done here. Let me add a new box. That's going to be blue, let's say, with the text of global configs, spanning tree, port fast on access ports, correct encapsulation on subinterfaces and trunk ports. And let's just do something global. Global NTP server of 192.168.100.100/24. So we're going to have this global configs for this network. And we're going to say, can you please refresh your information from the diagram, and please propose a network config for R1, R2, and switch 1 to enable working pings between PC1 and PC2. So let's see what happens here. So it's getting all cells again. And in the logs here, we should be seeing the read, right? We got the payload here. And here is the configs that it's proposing. So let's take a look at this. The network layout, PC1 is on subnet, PC2 is on subnet. So here's switch 1. Looks pretty good to me. There's router 2, it looks pretty good to me as well. And then there is router 2. So router 2 has the subinterfaces. I don't think we want that. So let's say, can you please only generate the R2 interface config facing R1? Can you please ensure encapsulation.1q as well as I'm thinking here it should be reading the text as well, not just the shapes. So let me take a pause 1 second. Okay, let me pause this 1 second. Okay, so I've made a couple tweaks here, which I'm happy with, and let's just see if I can actually read that. So let's just do this, and let's take a look at this side by each here. So, whoops, yeah, here. So we're going to keep an eye on the, okay, so it's already come in. What I'm trying to do now is get the text out of the, there we go, there we go. Now I'm getting the text, yes. Yeah, that's going to really help. So now, all right, now check this out. Now check out how much better this is. So before it was just getting the objects, and it was actually doing a pretty decent job. Now it's reading the actual text labels. So here we go. To enable successful pings between PC1 and PC2, we need to ensure proper routing and VLAN configs. Here's the proposed for each device. Router 1. Where's it getting the 20 from? I see. Let me fix this. This should be VLAN 30. Or, well, that should be VLAN 20. Let's just leave that as 20. And let's fix this to be VLAN 20. And this to be VLAN 20. But the IPs will remain the same. Let's do this again. That's human error. So let's grab this and try this again. It's always the human. It's always my mistake. Honestly, it's never the AI at this point. So there's the payload coming in. We're reading the text, which is awesome. Yeah, see the values here? PC1, router 2, switch 1. Okay, all right. All right, here's the new update. All right, so it's not reading this subinterface box here. I mean, the switch looks pretty good. There is no interface for. Okay, I'm really happy to show my progress here. I was getting the shape information, but not the connector information, known as edges. So I've tweaked the code a little bit, and check this out. So now, let me go to the Firefox, hang on. So now I have this. So what was happening is this information here about the sub interface is part of this connector. It's this end of the connector. It's not part of the circle. So I need to be able to get the edge information. Really cool. So now, here we go. Here on the right is the Docker. Now check this out. If I search for one, there it is right there. 1.1.1/30 is represented on the edge here. So it is extracting even more metadata from the diagram, right? So now, R1 is connected to switch 1 with subinterfaces connected on ETH0 for VLANs 10 and 30. 10 and 30. PC1 and PC2. And all the configs it's going to set up. Pretty wicked. Pretty wicked. Now, I don't see encapsulation on the trunk. That might be a problem here. We may need to adjust that. And I'm thinking in the diagram, let's take these trunk VLANs. Well, no, let's just leave it. Let's just leave it. I'm just wondering if, let me just question this. Does switch 1, right, ETH01 need encapsulation set? Did you not get this from the DrawIO information? Let's just challenge it and see what happens here. Human in the loop. It's really close. So, yeah, I think it's wrong. We can try that, but I think we need to set trunk, switch port trunk encapsulation. But let's go ahead and try it. So let's refresh this page and refresh. Let me save this and refresh this page. And we're going to load that diagram. And we have our connection. Let's go ahead and refresh this. For logging purposes, we're just going to refresh this container. And then we'll get the graph ready. So we should see the graph disconnect here. Yeah, there's the, now it's open again. All right, so now let's go back to our browser. Here, oh, I lost it. Sugar, okay. Can you please check with DrawIO network topology and generate proposed configurations for R1 and switch 1 based on the network diagram in DrawIO. Show me the proposed config. All right. So the first thing that's going to happen is the MCP pyATS is going to get all the information, and we can see these object requests coming in, which feeds back to the DrawIO to get all this information. And I think it's all there. And it's going to give us a proposed config. So there's the proposed config. And I think this looks pretty good. R1, switch 1. So let's actually ask for switch R2 as well. So let's refresh this. Say, can you please use the DrawIO network topology to propose, to generate and propose configurations for R1, R2, and switch 1. R1 and R2 is a P2P link. Switch 1 has PC1 and PC2. Actually, and I'm just going to say, that's all I'm going to say. And we're going to say the goal is to get PC1 and PC2 talking via ping. So we're going to see how quick this is. We're going to see it scrape the browser and then propose, right? There's all the scraped information. And then we're going to get the proposed config, which will come up any second here. All right, so let's take a look here. There's router 1, there's router 2. Oh, I see. See how it's picking up serial? A serial interface. And down here we're picking up Ethernet. So I don't have enough information in my graph. Let's enhance the graph. So I need to be specific about what interface types they are. I'll be right back. Okay, let's give this another go. I give it a little bit more metadata here that all interfaces are Ethernet interfaces, not serial or fast Ethernet. So let's grab this prompt and try this again. And we'll keep an eye on everything here. So there's the new scraped data. And we should see the proposed config here in a second. So there's the proposed config. Okay, everything is Ethernet now. That's good. It's even going to do OSPF. That's cool. Okay, let's go ahead. Can you please proceed to configure R1, R2, switch 1. And we'll go over here and we'll keep an eye on the running pings. I don't know if they'll just start working in time, but we're going to keep an eye on the pyATS, so configure device, and we're configuring R1. It's cool that it's not even using static routes. It's going to do OSPF. And now we're on router 2. And then it should be switch 1. Switch 1. And everything probably is done and configured. I don't see running pings yet. Did it enable interfaces and stuff? Let's take a look. We can take a look at what it configured. So what did it come back with here? It's not quite done. Okay. Yeah, you see encapsulation auto. Right, so do not configure ETH03. It is not on the diagram. And configure the correct encapsulation. I knew the encapsulation was a problem. It can't just be auto, it's got to be set. See there, the encapsulation.1q. Okay, so now it's been successful. You can verify connectivity. Whoops, sugar. That sucks. So let's take a look here. Show run. I mean, that all looks good there. Wrong port, Ethernet 00 there instead of 01. Okay, so that's a problem. These ports look okay though. What about the switch? Yeah, it's all mixed up here. Okay, let's try this again. Can you please analyze the DrawIO network topology and propose a configuration for R1, R2, switch 1 based on the metadata? So we've seen the request come in. We see the payload. And here's the proposed config. Hostname R1, Ethernet 00, subinterfaces. This looks remarkable. Let's try it. Please go ahead and apply the configuration, please. So we'll keep an eye over here on our running pings and see if they just miraculously start working. Am I not connected to the VPN? I'm on the VPN. What's going on here? Something wrong. Okay, there we go. Okay, calling R1. Next thing should be R2 or switch 1. Now we're on R2. Well, there's our ping. Cool. So R1 and R2 are pinging over this link here. This 10 or 1110/30. Pretty neat, right? I just say ETH01, ETH01. Here's the subnet IP. And then went ahead and we have working pings now between those two. So let's keep an eye on this. Okay, config's been successfully applied. I don't have running pings yet. Ping 10, 10, 10, 100. Something at the switch. VLAN 10, VLAN 30. That all looks okay. Subinterfaces .30, yeah. Whoops. So I can ping my gateways. Weird. Weird. I don't quite see. Is anything shut here? No, because I wouldn't be able to ping them. Show run. Just trying to see what it missed here. So this interface is fine. Is it because this is not no shut? I don't think so. No, because it would say shutdown. So the router looks okay. Show IP ARP. Incomplete ARP down to 100. And what about the switch? Oh, it's got the wrong interface. It should be interface 02 here, up to the router. Not, yeah, all right. I'll try this again. Okay. We're inching closer. I have a good prompt now that I actually asked the AI, can you help me make a prompt to make this work? So here we go. We're going to paste in the prompt. And we're going to see, you know, the payloads come back from the browser. There. And let's take a look at the config it's going to generate for us. Now we have to pay close attention. We can't just have a trunk link be on the wrong port. It has to be on the right port. No, see, it got it wrong here. Ethernet 00, that's not the correct one. Huh. Okay, all right, this is tricky, but let's try it. It's a prompt thing. So I'm going to say, do not assume which links are trunk links or access links. Please always refer to the DrawIO metadata. All right, let's try that. I'm having a problem where it's just assuming that this switch link is ETH00. But in the diagram, it's clearly ETH02. So let's see if we can force it out of it to get it correct. So let's see what it proposes here. Excuse me. Nice, see ETH00. Okay, this video is going to be fun because there's so many failures. It's always the human. I keep saying that. It's never the AI. It's me and mistakes I make. So I've been like I don't know, really hacking away at this. And it was the way I was adding things. So let me show you. I'll show you. It'll become, you might say, how can you make that mistake? It's pretty obvious to me. This particular shape that I add here is a connector with 3 labels. However, I misunderstood that as 3 text labels. What it really is a label on what it's connected to here, a text label, and what it's connected to over here. So, yeah. So I was getting the R1 and the subnet, but not the right interfaces. So after resolving that and moving my, both sides of the wire onto this label, let me show you what we have in the logs. So I've adjusted this to have 2 different tools, which is pretty interesting. One is to get all the cell details, and we have all the cell information that we're reading. And then I have another call here to get all the edge labels for the edges. And you can see there is some important information in the edges here. Right, see there's that new ETH01 break, the IP ETH01. So if we go to the prompt here, which was, don't reveal anything here. Can you please read the network topology diagram, both the shapes and the edges and connectors in DrawIO, and provide the recommended Cisco IOS XE configuration for R1, R2, switch 1, and enable PC1 and PC2 to ping each other. First get all the shapes, then all the edge data, and compose a proposed config. I'm going to copy this, And I want to show you the answer that I got, and then I'll do it live to show you that I'm not cheating. So this really is accurate. We have the encapsulation, the IP, the subinterface. We have the NTP server from the global instructions up here. We have the point-to-point link to the other router. The other router just has the point-to-point connection and the global NTP. The switch has the right access ports and VLANs and the trunk. The VLAN definitions in case this doesn't automatically create them, and the NTP server. So that should get running pings going. So let's go ahead and I already copied that. So let's tear it all down. I do want to do this live and together. And I will even tear this down. And what do I need to do? Okay, so we're going to bring up the containers and let the containers settle. And we're going to see all the containers start to appear here. We'll pay attention to DrawIO first, and then we'll pay attention to MCP. Now in the MCP, this is actually where it starts, but we can just monitor this DrawIO. So we're going to bring up our Firefox and go to our page. You can see that our client is ready. Open that existing diagram and hit F12 to bring up the console. And go back here and paste in our prompt. And let's watch how quickly this all happens. So don't forget the LangGraph, look at like it's almost instantaneous, right? And then back here, I should be getting, it's crunching all that data and coming up with the proposed config. And we'll take a look at it closely. Router 1, right? No shutdown, good. Subinterface, yep. Subinterface, yep. Point to point, yep. This is wrong. Where's it getting that from? Right here, Ethernet 02. So it's all right. All right, let me clean this up. Let me clean this up. We'll be right back. More failures. It's okay. It's all right. Okay, from here again, I just changed one little thing and I understand why I made the mistake, and I'll show you. I'll show you in a second. Let's let everything come up here. And all the code's pretty solid. I'm going to check this into the Git repo. All right, we can launch Firefox. We can load the diagram. Here, I've simply added a switch 1 and an R1 on this label to show it which side of the wire those interfaces are on. All right, again, it's always human error. So we're going to get our listener up. We're going to watch DrawIO. Before I quit here, let me grab that. Fix my typo here. And we're going to hit send. All right. So let's take a close look. Again, human in the loop. A couple misfires along the way here. That's okay. All right, here we go. So router 1, E0, subinterface.1Q. Yeah, it's no shut. One interface here. Wow, it's going to do OSPF. Cool. Very cool. Router 2, OSPF. Yeah, nice. 0, 1. Okay, put VLAN 20 on the trunk, which I'm not concerned with. That's fine. But I think it missed the encapsulation here. Oh, I know, it's my mistake. It's my mistake again. Okay, I'm pretty sure this one's going to work. I had just a little more detail to put into the image to help this out. We'll get everything up and running. and get our Firefox going. We're going to load our diagram. And I just gave it a bit of a hint here. I made a mistake on the VLANs. So I had VLAN 20 instead of 30. That's my mistake. It should be 30. Yeah. Yeah. Obviously human error there. Okay, let's try it again. Okay, we've got our data. We'll get our answer that we will interrogate. We've made our way through the two routers. I just didn't like that, yeah, right there. Switch port trunk encapsulation. All right, so let's make sure everything looks good from the top. It all looks really good, even OSPF here, which is nice. And access. Okay, so I'm going to say, can you please proceed to configure the devices with pyATS? All right, so now what we're going to do is here, a couple of things we're going to watch for. So let's get a ping going across the wire to each other from a PC perspective. Okay, that ping's already running. And we'll keep an eye on router 1, router 2, and switch 1's configs. It's not going to be in DrawIO, it's going to be in the pyATS client. Okay, so here we go. We've applied the config to router 1. And now we've applied the config to router 2. So in theory, I should be able to do ping 111112. Awesome. And ping 1111. Awesome. And can I ping 10.10.10.1 and 10.10.31? Router 1 and router 2 are good. Let's take a look at the switch. Okay, the switch config here. So we have our VLANs. We have our access ports and our trunk port. We even have the NTP server across the board, probably. Now, are the pings going to work? I can ping 10.10.10.100. I can ping 10.10.30.100. I probably don't have static routes on these clients. Right, so I need to do sudo IP route. That is out ETH0. I don't want to cheat and stop recording, but I'm pretty, like, the proof is here that, so I'm just missing routes on these Linux hosts. Yeah, I would have to add static routes onto these Linux hosts. Let's quickly vibe code that up. Static route to 10.10.30.100 or 0/24 via 10.10.10.1 on Linux. I was pretty close. What did I get wrong here? I'm not there here. And then the other side is going going to be the reverse of that. There we go. Yeah, like I said. So from no config to working pings on this router on a stick. And now I bet you if I check the routing table, yeah, I'm learning the routes on router 2 from router 1 through OSPF. So thank you for sticking with me. I like to include all these failures just to show you what I go through and what the development process is like a little bit. This is remarkable. One direction, can you get state from the network and draw something? And now the other architectural way, here's my intent as a diagram. Can you generate and validate the configuration and push the configuration? This is going to be a remarkable tool in the hands of the right people. So again, thank you again. Reach out if you'd like to get involved or try this code, and we'll see you soon.